So welcome to NX for Manufacturing Tech Tips. Today's tech tip shows how to use feature teaching and operation teaching to customize feature-based machining in NX. Demonstration will last approximately 20 minutes and we'll stay on the line. We'll open up a chat window for questions and answers. With that, I'll turn the session over to Tom Van Erve. Welcome, Tom. Let's get started.
Thank you, Derek. Welcome, everybody. As Derek said, we'll look at feature teaching and operation teaching, how you can customize feature-based machining to work with geometry and with operations that maybe we don't know out of the box. Few slides up front. The most important thing to realize is that last week's tech tip session that you can review was all about the user perspective, as Derek mentioned. This feature teaching and operation teaching is really an admin job. This is not something that we expect every user to do. On the contrary, that would probably result in chaos. Feature-based machining is extremely valuable if you can get it configured in such a way that you get all your users produce the same output, the same programs for similar parts. And the last thing you want to do is have each user teach his own operations and teach his own geometry. That is counterproductive. So we consider this to be an admin job. One key user from a team, and you'll see me do this live today, so it doesn't require any programming skills, but it does require some careful thinking. So it's an admin job that one person from a team, a key user, should be doing. The first step we'll talk about is feature teaching, and in the first session I showed you what feature-based machining could do, and one of the first steps is identifying features, recognizing the geometry in a part, and the software comes with an out-of-the-box library with a large number of feature types, but it might not have everything that you have in your parts. Geometry that is repetitive in your types of parts and that you would like to automate might not be recognized by our out-of-the-box features, and that's where feature teaching comes in. So with feature teaching, we're basically going to take some geometry and say, from now on, this is something that the software should recognize as a feature. Two things up front that need to be realized. A feature is basically characterized by a shape, a number of faces and how they're connected, what the edge relationship or convexity is it a smooth connection, is it a sharp connection between faces. So the shape, the topology, is independent from the position and orientation in the part, and it's completely independent of the size. The second part that is characterizing a feature is the size and location. So size attributes, anything you want and need, could be a length, a width, a radius, a depth, stuff that you need for your tool selection, for your operation selection. It could include tolerance attributes like a surface finish or diameter tolerances. It could include thread or even face attributes and face colors. And finally, it will also include a position and orientation of your feature. Believe it or not, for us and for NXCAM feature-based machining, these are two features of the same type. They have the exact same shape, the same number of faces. It's a plain floor with a fillet all around, connected to walls that are under an angle with respect to the floor, and that's it. Both are the same feature, but obviously they have different dimensions, they have a different location, they have different sizes. So with that, we'll get started in the live demo, and I'll start sharing my screen. For those of you that haven't seen NX feature-based machining in action, I would encourage you to go and find last week's tech tip session. I'll very briefly rerun two steps because I need them to introduce, but other than that I won't explain anymore how this is done from a user perspective. The first step in feature-based machining is to go and identify the features, use the find features command, and look for features that are in this part. And I'm using at the moment the out-of-the-box set of features, and I'm going to recognize everything that is in standard, but I'm not interested in individual surfaces, any turning or wire EDM specific shapes, and I'm going to go recognize my my geometry. That will quickly run through the part and give us a result that you'll see here. If I sort them and maybe briefly browse through them, you'll see a number of up-round holes. You'll see some tapered pockets. You might see a side notch, some partial slots, a rectangular slot, and a bunch of holes. But the thing that you may not see is you may not see any operations in these areas. Here, 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 because at the moment, if I select all of them, you'll see it better. There's no features in the standard library for these open slots that have the same shape that I used in my introduction. So the question is, what can I do to add this geometry that is recurring in my parts and that I want to automate? How can I add that to my library? And what we do for that is we basically isolate that specific geometry in a separate part. So I'm going to switch to a separate part that I've prepared, and in this separate part you'll see that I've isolated the geometry, and I'll explain in a minute why that's important to me, because this is going to be my source for feature teaching and later on operation teaching, and I would like to keep this part and keep it clean so that whenever in the future I want to make a change to my feature or my operations, my rules, I can go back into this part and modify it. Let's start with the very basic principle of showing you how feature teaching works. I can bring up the command teach features. I get a dialog where I need to define a name for my new feature type, and I put this under a library that I call custom features. I'm going to introduce a new type, and I'm going to call it tech tip. And I have a bunch of libraries with recognition rules. I'm going to put my new recognition rule that I'm going to generate in a second under my sample library. The last thing I'm going to do is select the faces in my cut part that are of interest to me, and I'm going to say, okay, teach a new rule. It says, okay, I've done that, and I'm going to store my new recognition rule. It's going to save this into the machining knowledge editor, but we don't see it. We'll look at it later on. If I now open the dialog again, the find features dialog, you will see that the software has added a new tech tip feature. Actually, I'm not so much interested in the rest anymore, and I can now go find this. And I have a new tech tip feature recognized. Now what you may see is that this already comes with a position. You can see the coordinate system there. It comes with some attributes. It comes with, I think, an angle parameter that's in there. And you may wonder, how did the software know to extract that position, and how did it know which attributes I'm interested in? And let me show you that. So I'll remove the feature for a second so it's gone again. And I'm going to switch on a different view in which I have some PMI predefined. Now, those of you that are working with PMI may be familiar with this. I didn't put any effort into putting the PMI on the part nicely, but I did use some PMI and basically for the purpose of feature teaching. So I put an angle dimension on this cut part and said I'm interested in the angle between this floor face and the wall, and that's going to be a parameter, an attribute of my feature. In a similar way, I put a surface finish on the bottom surface of my, my feature, and I gave it a name. I called this bottom roughness, and that's another attribute of my feature. What I also did is I defined a coordinate system, and the coordinate system, I put the position at the location of the arc that you see highlighted in orange. I put the z-axis as the face normal of my floor face of the geometry, and I put my x-axis, if we want to see it in detail, as a 2-point vector from the center of the arc in the back to the center of the edge in the front. So I put some PMI and a coordinate system on this part to help me teach information on the feature. And I'll do some more, one more. I will add an inferred dimension. I'm actually picking that edge, and I'm saying, okay, I'll put a PMI on there. And what I'll do is I'll make that a toleranced PMI. I'm actually going to put in some tolerance values, 0.3 minus 0.3. And I'm going to add a text at the end of my PMI. I'm going to say that this should be recognized later on as my length attribute of the feature. So if I now go back and teach the feature one more time, actually immediately selecting the rule that I created earlier, reselecting the faces, actually overwriting the previous recognition rule, I'm now done with my recognition, with my teaching, and I've created a new feature type. I switched to my original model. You remember that I had a bunch of features there, but I didn't have any geometry for these areas. No feature. I can now go back in, have my tech tip features taught, recognize, I find 3 of them. You'll see where they are. And the extra thing that I would like to show you is that if I order the attributes, there's now also a length in there. That feature has a length of 47 something. That has the same length. This one is significantly smaller because the PMI that I put on the cut model helped me understand what the attributes are that I'm interested in. So it picked up the angle, it picked up the bottom radius, it picked up my surface finish, it picked up my length, and in this way I now have a new feature in my library. Okay, looks good. I'm happy with that, but I didn't find this geometry here, and I'm interested in that as well. Now, you probably figured out by now why that was not recognized. It's basically because it has a different topology. It doesn't have the blend surface in there, so it has a different number of faces. It has a different topological situation, so it's not picked up as the same tech tip feature. However, it's very similar, so maybe it still is a tech tip feature. And I can now go change to a different cut model where I've already put the PMI on, and I've also put the coordinate system on. And this is a variant without the fillet, as you can see. And what I would like to do is now teach the same feature type, but instead of overwriting it, I would like to create a second or alternative rule for this feature type. So this is going to be my tech tip no fillet recognition rule, if you will. Selecting the faces, teaching the rule, saving it to my knowledge editor. If I switch back and see what we have, maybe I'll just remove those for a second and go back and do the find features. You'll see there's still just one type. I didn't add multiple types. called all of this my tech tip feature. But I now have two recognition rules. One that finds the geometry with the fillet and one that finds it without the fillet. So if I now go recognize it, it finds 4 features. And obviously, if we look at the details, show that a little bit better. You will see it has a length, it has an angle, but it doesn't have a bottom radius because it doesn't have a fillet. Of course, it does have the attribute. It does have the attribute bottom radius because it's the same type, but in this case it doesn't have a value. It's undefined, and normally we hide undefined attributes, so it wasn't shown. But what I've done now in summary is basically created 2 recognition rules for 1 feature type, and I'm now able to recognize these shapes in just about any type. What we did last week was basically show you how create feature process works, right? In this part, I've created a cavity milling operation to rough out some of the blank area there, but that's not too important. But other than that, I don't have anything. I don't have, that's the only operation I have. I have a single tool. Typically, I would use the create feature process and look at the library of rules that I have, typically my mill drilling, and I would try and get a recommendation for machining operations. And with the standard capabilities, the out-of-the-box installation, it will now give me operations and tools that meet my criteria for these holes. Right? So that's what we did last time. And looking at the geometry, I now have a bunch of features machined with spot drilling, drilling counter milling, some others, slightly different operations, same operations, different tools for the holes there that are slightly smaller, right? So that's what I would expect I would be able to do with my new features. So what happens if I pick my new tech tip features and ask for a process? And you'll probably understand that it will fail. It basically says no knowledge available for feature tech tip, so no operations generated, right? It doesn't know how to machine a tech tip feature. So the next step we need to do is what we call operation teaching. Before I do that, let me bring you back to the create feature process and show you the available libraries with know-how. There are 4 of them. And I want to isolate my changes, so I'm going to now go switch to the machining knowledge editor, open my XML file that basically contains all the feature-based machining customization. And in our next tech tip session next week, we'll show you more details. But this is basically where that dialog came from. And for the sake of this this demo, I'm going to introduce a new machining rule library, and I'm going to rename that in tech tip rules something, right? I'm saving it, and I'm closing my XML again. So now I know I have a place where I want to put my new rules. How do we create new rules for these features? It's pretty much the same thing. We call it operation teaching, and I'm switching back to my cut model. And within this cut model, I actually not only created the geometry, I also created, using regular NXCam, I created a mill area, I created a roughing operation, a cavity mill pocket roughing operation, I created a cavity mill pocket finishing operation. And we can just go look at it. Those are regular operations, and maybe let's just look at the constant depth per cut, which is set to 3 millimeters. Just for the demo, let me change that to 3.56. Remember that number. We'll look at it later, right? So I have 2 operations that I could apply to this feature. before I can do operation teaching, I of course also need to recognize the feature. So I'll do that briefly. Bring up the dialog. In this part, recognize my tech tip feature. And what I want to do now is basically say, those two operations, I want you to automatically create rules from those two operations. Object, teach operations, brings the dialog, says, where do you want to put those rules? Well, I didn't want to mix them with my mill drill. I want to put them in the library that I just created, the empty library, in my tech tip rules library. What's the feature you want to associate these rules to, these operations to? I can go select that and say go teach it. You will now see that the software has created two additional rules in the library, a pocket finishing for the tech tip and a pocket roughing for the tech tip. And I'm going to save that. If I now go back to my demo part where I had, if you remember, my 4 features, I should now be able to use my new rules. I can do create feature process, and I'm not going to use my standard library because we tried it and there's nothing in there that works. We're going to use the new tech tip rules library that I created earlier, and we're going to try and run that process. You see, I've never left NX. I didn't do any coding. I didn't do any complicated stuff yet. I'm going to do some more complicated stuff in a minute. And I got automatically created a mill area for those 2 features and a roughing operation and a finishing operation that I can now just generate. And because I don't want to waste too much time, I'm going to throw out the holes and generate that quickly. The regular cavity mill operations, and they were just created automatically for me, and that's the toolpath that will be produced for those, right? However, you will notice that I only was able to get operations for those 2 of the 4 features. The other 2, I did not get a solution. And that's because when we do operation teaching, we make the rules very specific. We say that only if we find the exact same feature, not just the type, but with the same dimensions. We don't care about location and orientation, but it has to have the exact same dimensions. Then we can apply the same process. But one of these features, that one, definitely doesn't have the same dimensions. It has a different length, it has a different fillet or bottom radius, so we couldn't apply it. And the other one not only has a different length, it doesn't have a fillet at all, so we couldn't apply it. Now what we can go do is open up the machining knowledge editor again, open the same machining knowledge XML file that we were working with, and again, more details in the last session next week. Look at the stuff that was there. Previously, there was an empty tech tip rules library. It now is populated with 2 rules that were automatically generated. I won't explain all the details of the machining knowledge editor, and I won't explain all the details of the generated rules, but have a look at some of these conditions. Right? It basically says I can do this operation if my feature has that specific angle, if it has that specific bottom radius or fillet radius, if it has that specific length. Only then can I apply my rule. Now let's just remove that for test purposes. Let's make the rule more generic. So I'm saving my my changes. I'm leaving the machining knowledge editor up. I can actually delete that for a second and run it again. So I'm now going to take all 4 features again, asking for the create feature process one more time, and hopefully I now get operations for all 4, because it no longer demands that the feature is matching exactly the feature that I used to teach the operations. Guess what? It works. That's the good thing with the demo. I now get the same roughing and finishing operations for all the 4 features. But wait a minute. The finishing operation was actually using a tool with a, if you will, 3.2 lower radius, bottom radius, that would match the fillet. And that's perfect for these 2 features up front here, but it doesn't match this one, and it certainly doesn't match that one. So I made my knowledge a little bit more generic, but that wasn't a good change. What I would actually want to do, and this is the last change I'm going to make, I'm going to look at the tool selection as well. So the rule that was created for the finishing operation says I need an end mill. That's the tool type that I need. And it's actually looking for a tool with a specific corner radius and a specific diameter and flute length and taper angle, even lip rev. And that's not what I want. So let me make this a little bit more generic as well. Let me say I basically want to add a condition that says if my feature has a bottom radius, if it has a fillet, then I want my tool corner radius to match my bottom radius in the feature. And if it doesn't have a bottom radius, I want to have a sharp tool. I want my tool to have a corner radius of 0. And I could just define that by saying if, using a function, is defined my feature bottom radius, right? If that has a value, then I want my tool corner radius to be equal to my feature bottom radius. Else, with the correct typing, I want my tool corner radius to be equal to 0. Right? So now, obviously I need to delete my original condition. Now I've made my rule a little bit more generic. I've said I can always apply it, but I have to make sure that I select a tool where the corner radius matches my feature. So I'm saving this, and we'll again have more details on this in the next and last session. I'm deleting the previous results, and I run this one more time. Create feature process, and hopefully I now get different tools selected for the different features. With me changing that condition, you can obviously see that now it becomes more of an admin job. This is not something that we expect every user to do, but it's not rocket science. And the outcome is pretty good. I now have this feature with its operations. I have those 2 with their operations, and I have that one with its own operations. And if I just look at the finishing operations, and look at the tool, that has a sharp corner. I picked a tool that was way too big because I removed everything else, but it has a sharp corner. So I'm not finished yet, but it did do exactly what I wanted. That is still hopefully using the tool with the 3.2 radius. And last but not least, this one is using the tool with a 2 mm bottom fillet, right? So I made a small change in my rule, and as a result, I get different tools selected from the same rules. And last but not least, all of them are actually using a 3.6 or a 3.559 constant depth of cut, because all the settings that this operation has, its cut levels, its non-cut, its everything, its pattern, came from the operation that I used to teach it. So it's automatically duplicating whatever I had in the operation that I used to create the rules. So with that, I'm basically at the end of my my demonstration. We can go back and stop sharing. Maybe go back to the PowerPoint for one last summary slide. So we've done feature teaching, we've done operation teaching, and we've basically seen that that too is an admin job. I picked some operations, automatically created the rules. I did that in the demo, and just want to point you to the next session, the last session in this series of 3, where we go into more depth on the Machining Knowledge Editor. That's the application where you saw me make the tool condition changes. We'll show you a little bit of how that works, and hopefully with the 3 sessions together, you will have gotten a good idea of how you can add additional features to the NXCAM feature-based machining, and how you can add additional rules to NXCAM feature-based machining. So with that, thank you for your attention, and giving it back to Derek.
Great. Thanks, Tom. I'm sure we're all inspired to go define some new features and processes in our shops. I want to encourage everyone to join us next week for the 3rd webinar in the feature-based machining series, where we'll dig deeper into the customization options available in the Machining Knowledge Editor. As always, the conversation continues at our discussion forum, where we'll post these questions and answers that we come up with here, as well as any following topics that you pursue there.